Google Sheets, being one of the most popular spreadsheet applications today, is being used by thousands, if not millions, of individuals, teams, and organizations worldwide for tasks ranging from simple data tracking to complex data analysis and project management. In the past, we would spend countless hours on manual data entry, complex formulas, managing tabs, and troubleshooting errors. It was inefficient, often frustrating, and prone to mistakes. Workflows were fragmented, requiring add-ons or external tools to fill the gaps. By building our own Google Sheets AI agent, we can simplify and automate these processes, turning tedious tasks into seamless, efficient workflows. In this tutorial, I am going to walk you through how to create your own Google Sheets AI agent using PydanticAI in Python. If you're new to PydanticAI, PydanticAI is a Python framework that streamlines the creation of production-ready LLM agent applications powered by large language models. Developed by the creators of Pydantic, the framework emphasizes type safety and modularity, supporting various large language models like OpenAI, Gemini, Ollama, and Anthropic. Before diving into the tutorial, you'll need to have a Google Cloud account, access to an LLM model, some experience working with Python. If you're a Patreon member, you can download the source code from the link in the description below. Now, to get started, we are going to set up access to Google Sheets API first. Navigate to console.cloud.google.com. Select the drop-down on the top and click New Project. Give your project a name and click Create. Click Select Project once project is created. Now let's enable Google Sheets API. In the navigation menu, under APIs and Services, click Library. Navigate to Google Sheets API and enable the API. Now let's configure the OAuth consent screen. The purpose of this step is to define how the app will request Google Sheets permission and how it will appear to users, ensuring transparency in what the app can access. In the navigation menu, under APIs and Services, select OAuth consent screen. Click Go to New Experience if the option is presented. Click Get Started. Give the app a name and follow each step to complete the configuration setup. For the audience type, choose External. Right now, the app is in the testing environment. To grant users to access the project, in the navigation menu, click Audience. Click Add Users and add the user's email you want to grant access to the project. If you decide to publish the app, which requires go through Google's verification check, your project will be accessible by anyone. At this point, we are done setting up the OAuth consent screen. The last step is to create an OAuth client ID. On the navigation menu, click Clients. On the top, click Create Client. If the Configure Consent screen is showing like what I have here, press F5 to refresh the page. You should see the application type drop down once page is refreshed. For the application type, choose Desktop App. Give the client ID a name, then click Create to create the OAuth client. Click the download icon to download the client JSON file in your project folder. For the client file, name it credentials.json. At this point, we are done setting up Google Sheets API in Google Cloud. Let's move on to the Google Sheets agent development. Launch your terminal and run the command showing on the screen to install the Python dependencies. To simplify model creation and for reusability, open your IDE and create a Python file, name it loadmodels.py. In the Load Models module, initialize the model you want to use with your Google Sheets agent. In this step, it's really depending on the model provider you're using. I will be using Google's Gemini 2 Flash model for the tutorial. OpenAI GPT-4o and Anthropic Claude 3.5 Sonnet models also work really well. When connecting to Google Sheets API endpoint, create a Python file and name it googleapis.py. In the Google APIs module, import the required Python packages like what I have here. When connecting to Google APIs like Gmail, Drive, or YouTube, the setup is exactly the same. The only thing that's different is the API service name, API version, and permission scopes to connect to a specific Google API. To streamline the process to connect to a Google API service, create a function called createService with the following required parameters: client secret file, API name, API version, scopes, and an optional parameter, prefix. When using the function to connect to Google Sheets API, we will pass the credentials file we downloaded earlier and specify Google Sheets service detail. If we quickly go through the createService function, inside the function, we will set up the procedure to generate a session token file to store the authenticated session. This ensures that the next time when we connect to a Google API service, we won't need to repeat the authentication process. And here's the rest of the function. Now let's move on to the Google Sheets agent development. Create a new Python file and name it sheetsagent.py. Import the Python packages showing on the screen. The reason why we need the SSL Python package is due to the fact that occasionally we might run into SSL error when making a request to Google API server. This happens if you're sending too many requests too quickly or SSL certification verification fail. We will use the SSL package to catch any SSL related errors. There are so many things we can do in Google Sheets, and for demonstration, we will equip the Google Sheets agent with 3 functions: one function to add worksheet, one function to delete worksheet, and one function to list worksheets. With just these 3 functions, we can actually achieve quite many things, which I will share examples later. PydanticAI uses dependency injection to provide predefined variables and objects for an agent to use. To give our Google Sheets agent access to connect to Google Sheets and Spreadsheet, define a data class called Sheets dependencies with 2 fields, Sheets service and Spreadsheet ID. Depending on your use case, you can extend the fields if needed. And to ensure the Google Sheets agent output to stay consistent, define a base model class called Sheets result. You can think this as the same thing as structured output. For the output, we want to return the status of an API call and result description in string format. To connect to Google Sheets API, create a function called init Google Sheets client. Inside the function, define the variables to construct a Google Sheets API service instance using the createService function and return the service object. Now using the agent class to create our Google Sheets agent. In the agent creation, define the model, dependency data type, result data type, system prompt, model settings, and retry count. If we look at the system prompt here, you'll notice that I specifically instruct the agent to delay each API call by 1 second. This is because certain operations, such as deleting sheets, require a slight delay between requests to prevent rate limit error. By introducing a 1 second delay, we avoid issues where API calls might get stuck due to being sent too quickly. To add a worksheet, create a function called addSheet with 2 parameters, ctx to reference the run context to retrieve the dependencies, and sheet name to name the worksheet. To add the function to the agent's toolset, register the function with the tool decorator, and set the retry count to 2 in case if the request call failed. Similarly, to delete a worksheet, create a function called deleteSheet with the same parameters as the addSheet function. When deleting a worksheet, we actually need to pass a worksheet ID. To figure out a worksheet ID, we will use spreadsheet's get method to get the worksheet list in the Google Sheets file. Then iterate through each worksheet to find the matching sheet to obtain the worksheet ID. If worksheet ID is not found, we can assume the worksheet does not exist. Otherwise, make a request call to delete the worksheet. To list worksheets in a Google Sheets file, create a function called listSheets and register the function with the tool decorator. That's everything we need to do to set up the Google Sheets agent. Now open an existing Google Sheet or create a new Google Sheet file. Back to the Python script. Insert the main routine, assign a Google Sheets ID to the spreadsheet ID variable, and call the init Google Sheets client function to construct a Google Sheets service instance. For the dependency, create a Sheets dependencies object and assign the service object and spreadsheet ID as the arguments. To launch the Google Sheets agent, use the input function to accept requests from a user, then use runSync function with the dependency to send the request. And to keep the chat session live, we can use a while loop. In the example here, we are assuming each request is independent. If you're working on a project and you need the agent to track the actions and logs, in that case, you can include message history like what I have in line 160. Now let's test the Google Sheets agent. When you run the Sheets agent script for the first time, you will be prompted to log into your account. Sign in to your account and grant the permission to the app. Once you're authenticated, a token file will get generated in the token files directory. Next time when you run the script will check if a token file is available and load the token file to restore the previous session without the need to log in again. If you need to change an account, simply delete the token file and rerun the script. For the first request, let's ask the agent to list the worksheets. From the output, which is a Sheets result data object, the request status shows true, meaning the API call is a success. And result details is the string response from the Google Sheets agent. For the next request, let's ask the agent to create 12 worksheets from January to December. Okay, so this is a new error to me, but from the error message, I am pretty sure this is the issue with Google's Gemini's server. Most likely, the server is busy or the agent is making too many requests too quickly. But we can see that January to August worksheets got created before the error. Let me restart the agent. This time, let's ask the agent to delete worksheets from April to August to make sure we don't run into the resource exhausted error again. From the log, we can see that the target worksheets are deleted successfully. So yeah, rate limit is definitely something to consider when giving an agent tools to use. For the last two tests, I will simply ask the agent to add and delete a worksheet based on a condition. And the agent executed both tasks perfectly. And that covers everything in this Google Sheets agent tutorial. Hopefully you find this video useful. If you're a Patreon member, you can download the source code from the link in the description below. And don't forget to like the video and subscribe. Happy coding. See you in the next one.